Today we are talking about trigonometric functions under calculus. Trigonometric functions. Now, but let's start with the standards because we have some basic standard under trigonometry. So standard differential of trigonometric functions. So these are the standard we have to know before we can launch into the calculation aspect of trigonometric function. So the first one says d ds of sine x. It means if I differentiate sine x, it will give me cos x. Note, d ds of sine x is still dy dx, where our y is sine of x. So, which means d ds of sine x gives cos x is standard. Although it has proven, but we are not going there. But it's standard that differential of sine x is cos x. Now, it is standard that differential of d dx of cos x gives minus sine x. And it is standard that d ds of tan x gives sec square x. And it is standard that d dx of sec x, sec means seconds, that's full pronunciation. D dx of sec x is sec x tan x. And d ds of cos x is minus cosec square x. And the standard differential of cosec x is minus cosec x cos x. So these are the standard that we have to know before we can dive into the calculation aspect of trigonometric functions. So let's start from the examples. So let's solve these questions under trigonometric functions. Question 1 says y equal to sine 4x, differentiate. Solution. We are given y equal to sine of 4x. As you can see, this is not a standard. From the standard, differential of sine x is cos x, but it has been composed. We call this composite function. Based on our last video, I said composite function means a function in which it is imposed, like there is a function inside a function, which means there is now 4x inside sine, which means we cannot differentiate direct because it is not in form of the standard. So we have to use chain rule in this case. I will now say let u to represent what is composed in sine, which is what? 4x. So I will now say let u to be what? Let u to be 4x, which implies that y will be what? Sine of u. Since my u is 4x, from this u, I can generate du over dx. That is differential of u with respect to x. The answer will give what? The answer will give 4. From this y, I can generate dy over du. If you observe, sine of u, sine of x is now in standard, like it is a variable, is now in standard, so we can easily differentiate sine of u. So differential of sine u gives cos u, since we are dealing with u, not x. So now, therefore, using chain rule, therefore, dy over what? Dx will now be what? Dy over what? Du times what? Du over what? Over dx. Just slot in the values we have gotten. What is dy over du? Cos u. Cos u times what is du over dx? 4. 4. Which means, therefore, you can now conclude that dy over what? Dx will be equal to what? 4 cos u. 4 cos u. Now, you now recall that since you are giving question in form of x, not in form of u, you now recall that u is what? 4x. So, therefore, dy over what? Dx will be equal to 4. Recall that u equal to 4x. So, dy over dx will now be 4 cos u. What's our u? 4x. That is the final answer. This is the standard method, but you can also use shortcuts. Shortcut says, instead of going through all this process, this is the standard method for solving theory. But if you are dealing with CBT or objective, you can just, within few seconds, you can get your answer. Just look at the question. Just differentiate the one that is composed. If you differentiate 4x, it will give you 4. Then, which is 4. Multiply it by, if I differentiate sine, it will give me cos. That is cos of what? 4x. The answer will now be 4 cos 4x. Shortcut, differentiate what is composed, then find the differential of sine, which is cos, it will now be 4 cos of 4x. That is the shortcut. But this, my normal method, is the standard method for theory in any exam. That is for question 1. Number 2, we are given y equal cos square x. If you observe the nature, it is not in form of standard. The standard is cos x, or cos of a variable, or ordinary variable. It can be cos of x, it can be cos of u, but this one is cos square. Note that cos square x means cos x times cos x. That is cos x multiplied in 2 places. So there is no way you can differentiate direct. So in that case, you have to use chain rule. It has been composed in 2 places. You now say let u to be equal to cos x, which means if u is cos x, then y will be what? U squared. Why? Because cos square x means cos x times cos x. Since one of it is u, then it will now be u squared, which is representing cos square x. From this u, I can generate du over dx, differentiating u with respect to x. My answer will be what? Differential of cos is minus sine x from the standard. If I differentiate cos x now, it will give me minus sine x. Now, from this y, I will generate dy over du, which give what? 2u. Now, using chain rule, therefore, dy over what? Dx will be equal to dy over what? Du times what? Du over what? Dx. What is dy over du? It's 2u times what is du over dx? Minus sine x. So in conclusion, we can now conclude here that dy over what? Over dx equal to, normally this is our solving, 2, it will now be 2u sine what? Sine x. Then because of the minus, it will be minus 2u sine x. Don't forget, we are solving with respect to x, not u. You will recall that what? U is what? Cos x. From the beginning, we say let's use to be cos x. So you substitute the value back. So therefore, dy over dx equal to minus 2 times, what is our u? Because you can just say minus 2 sine x times u. Our u is what? Cos x. So dy over what? Dx will now be minus 2 sine x cos x. This is the final answer. But recall, we can stop here, it's very correct. But in some advanced exam, they might not stop here. There's a particular identity in trigonometry. It says, it's proved that 2 sine x cos x equal to sine 2x. There's a way we can prove it. It says that 2 sine x cos x equal to sine of 2x is under trigonometry as a topic. So we can stop here in theory, but if you are dealing with advanced or objective, they might say the answer is sine of 2x, which means we can substitute or represent 2 sine x cos x as sine 2x. Don't forget there is minus there. So we can now conclude that dy over what? Dx is minus, because of the minus here, and 2 sine x cos x is what? Sine 2x is a standard. So that is sine 2x. So dy over dx is minus sine 2x. That is the final answer for question number 2. For number 3, we are given that y equal to cosec 3x. For question number 3, we are given that y equal to what? Cosec 3x. It is not standard. Don't forget that I said the differential of cosec x standard is minus cosec s cot x. That is standard. But indeed, it has been composed with 3x. It is not standard anymore. So we have to use chain rule. I will now say let u to be equal to what is composed inside, which is what? 3x. So from here, I can now say that since u is 3x, my y becomes cosec what? U. Since my u is now 3x. From this, I can generate du over dx. Differential of u with respect to s gives 3 in this. So from here, I can generate dy over what? Du. If you observe now, it's non-standard cosec u. So differential of cosec u will give us minus cosec u cot u. Please don't do mistake. For x, differential of cosec s is minus cosec x cot x. But for u, it will be minus cosec u cot u. So using chain rule, therefore, dy over what? Over dx will now be what? Dy over what? Du times what? Du over what? Over dx. So dy over du will give us what? Minus cosec u cot u times du over dx gives 3. So in conclusion, we can now conclude that dy over what? Over dx. Based on what we got here is what? There is minus here equal to minus 3 cosec u cot u. But don't forget, you are given question in form of x, not in form of u. Then you recall that u equal to what? I said let u to be equal to 3x. Recall that u is 3x. So in your final answer, dy over dx will now be minus 3 cosec u. Where your u is what? 3x cot u. Where your u is what? 3x. That is the final answer.